Hi, so I wanted to come and go over this one question that we had ended with at the end of class period. The problem says, from a group of 20 volunteers, how many different ways can we choose at least 4 to be peer counselors? We talked about how it said at least 4, and so that would be 4 peer counselors, 5 peer counselors, or 6 or 7 or 8, all the way up to 20. And so that would be a lot for us to look at mathematically. So if we look at the complement of at least 4, that would be no peer counselors, 1 peer counselor, 2 peer counselors, or 3 peer counselors. If we choose a group of people, let's say 3 people, because they're peer counselors and there's not a particular job for them besides just being a peer counselor, it doesn't matter the order that we pick these in. And so we're going to use combinations here. And so if we were looking at, there's 20 people and they can either have no peer counselors, which is 0. So choose 0, or we could have 1 peer counselor, so 20, choose 1, or, so plus, remember, or we talked about being plus, or 20, choose 2, or 20, choose 3. So this is just the complement of at least 4. So looking at the following, we then set it up using the fact that this is combinations. We look at how many objects, which are 20 people, factorial, all over 20 and minus r, so 20 minus 0 factorial times 0 factorial. Plus, so 20, choose 1. This is 20 factorial all over 20 minus 1 factorial times 1 factorial. Plus 20, choose 2, so this is 20 factorial all over 20 minus 2 factorial times 2 factorial, plus 20 factorial all over 20 minus 3 factorial times 3 factorial. So we kind of did this math in class and we rewrote this and simplified by canceling like factors in our numerator and denominator. So 20 minus 0 factorial is 20 factorial. So we have 20 factorial here divided by 20 factorial. 0 factorial is 1, so let's just drop it. Plus, here we have 20 factorial in our numerator, which is the same thing as 20 times 19 factorial, all over 20 minus 1 factorial, which is 19 factorial, times 1 factorial, and 1 factorial is 1, so I'm just not going to write that down. Plus, then I have 20 factorial all over 20 minus 2 factorial. Well, 20 minus 2 factorial, that is 18 factorial, times 2 factorial, which is 2 times 1. And that 20 factorial in my numerator, we're going to write it as 20 times 19 times 18 factorial. Plus, let's first look at the 20 minus 3 factorial. 20 minus 3 factorial, that's 17 factorial, times 3 factorial, which is 3 times 2 times 1. And so let's rewrite in the numerator that 20 factorial as 20 times 19 times 18 times 17 factorial. So let's cancel what we have in common. So for that first fraction, 20 factorial over 20 factorial, that is 1. Plus, we can cancel our 19 factorials here, which gives us 20. Plus, so notice here our 18 factorials cancel. 2 goes into 20 10 times. So I'm left with 10 times 19. 10 times 19, that's 190. Plus, so let's simplify here. So 17 factorials, those both cancel. 3 goes into 18 6 times. 2 goes into 20 10 times. And so multiplying what we have left in our numerator, 10 times 6 is 60 times 19, that gives us 1,140. So summing these values up, we get back 1,351. 1,351. So this is the way, or number of ways that we could choose at most 3 peer counselors from 20. That's the complement of what we're trying to find by choosing at least 4 of our peer counselors. So we need to look at how many ways can we choose 20 people, and the different subsets of that. And so recall when we were looking at subsets before, we looked at 2 raised to the power. There's 20 objects. So if we go 2 to the 20th power, that's going to give us 1,048,576. So we're looking at the complement again. So the number of possible subsets of 20 people is that 1,000,000, again, 48,576 minus the complement of at least 4, which we found was 1,351. And so if we calculate this out, we get 1,047,225 ways that we could choose at least 4 of the people to be peer counselors. So hopefully this clarifies what we were doing at the end of class and how to do that problem.